Okay, welcome back, Math 10s. This is going to be our lesson on 5.4. So recall in our last lesson, we learned our first main form that we use, y equals mx plus b. That one is called slope-intercept form. Slope-intercept form. Okay, and it looks something like this, where we have it solved for y on the left side, and it's equal to mx plus b. And it's called slope-intercept form, remember, because right here is our slope, our m, our rise over run, and right here we have our intercept, specifically the y-intercept. And we're able to graph lines really quickly. There's another form that is useful in certain situations called slope point form. Okay. This is another way that an equation of a linear function can be written. Now, instead of a y-intercept as a starting point, we just use another point. That's the only difference. Okay, so it looks a little different, but the slope again is used to find the other points of the line. So we're still using m the same way we did the rise over run. And what this looks like is if we have an equation of a line that passes through the point, we'll call it P, and it's x1, y1, and has a slope m, the formula looks something like this. Y is our variable, and subtract y1, okay, so whatever the y1 value is here, and that's equal to m multiplied by, in brackets, x subtract the x1 value from the point P. Now, a couple key things here I just want to point out. This is the exact same thing as before. This is our slope, our rise over run. Now, really important though, and we're going to pick up on these, is that this has to be in the form of subtraction. We have to be subtracting here. If it isn't, we're going to do a quick modification and actually change it into a double negative or subtracting a negative. And we'll deal with that when it comes up. So, and just to notice that the slope point form comes directly from 5.1, our original equation for the slope. Okay, looking like this. It looks a little different. I know usually it had a y2 and an x2 here, but we're saying just in general. Okay, so just in general here, if y and x were variables and we subtract the point, well, we can solve this, or we can modify this equation by multiplying both sides by the denominator. We can multiply by x minus x1 on both sides, x minus x1, and we can discover that these cancel and we're left with our formula just up above for slope point form. So let's see what this looks like. Let's graph a couple and let's see how we use this. Okay, so we want to graph this linear function. So we can see it's in slope point form. We can see we have a slope here multiplying by x subtracting something. We have subtraction here and here, so that is a good thing. Okay, so we can discover our point is our, so P is going to be equal to, the slope point is, here's our x1 value, which is 1, and our other value is our y, which is 2. Okay, so we have our point and we have our slope where m is equal to 1 over 3. So the way to do this is we are going to plot our point first. We used to plot our intercept first with slope intercept, but with slope point, we plot the point first. So that's at 1, 2, which is right here. And just as before, we're going to use our slope to get our next point. So up 1 to the right 3. Now I fall off the graph if I go that way, so let's go reverse it. Let's go down 1 to the left 3, down 1 to the left 3, and we see we get our line right here. And really similar process. So when it's in slope point form, we find our point, okay? P is equal to 1 and 2, okay? This came from here. That's our x1. And here's our y1 right there. Okay, so plot our point and then use our slope to get more points. Okay, here's one of those situations that I was just talking about. We have y plus 4. This is not good. Let's give that a sad face. We cannot convert this just yet. So we has to be subtraction, but it's easy. Addition can be changed into subtracting a negative. We've never done this before, but it looks like this. And now we know that what I've written is the exact same thing. I've changed that addition into subtracting a negative, and now I can find my point. My point P is going to be equal to, here's my x1 now, is 3, and my y1 is right there. So I'm going to grab this point, my x1, y1, and it's going to be 3 and negative 4 this time. Okay, so we definitely treat these as subtractions, and then we grab the sign of the number. And so let's plot that point first. That's going to be a positive 3 down 4, which is right down there. And next, let's use our slope. We see our slope is right here. We're just going to put it over 1. We have negative 2 over 1, so m is equal to negative 2 over 1. So we're going to use that slope to plot some points. So down 2 to the right 1 gives me a point. I can't go any further, so let's reverse that. Let's go up 2 to the left 1, up 2 to the left 1, and let's just fit as many as we can, so it makes it a little easier to draw this line. And all the way through my points, all the way through the graph, and an arrow at each end indicating that this line goes on forever. Okay, let's take a look at this one. Can we create an equation given a graph? Yeah, this actually isn't too hard. We can simply find a point on our graph first, and we can also determine our slope. So let's start with our template. We know it has to be y equals y1, and that's equal to the slope multiplied by x subtract x1. So we need a slope, and we need this point. Well, let's get our slope first. Slope, we can see we have 2 points that are already indicated here from here to here. So let's switch to green maybe, and I'm going to get my rise over run. So it goes up 1, 2, 3. So I got a plus 3 here, and then it goes 1, 2, 3, 4. So plus 4. So we can see my rise over my run is 3 over 4 just by reading it right off the graph. Now, the point we're going to use doesn't matter as long as it is a valid point on the graph. So we're going to use this one right here. Okay, we're going to use this point, and that's at -1, -2. And we're going to plug that in. So that's my x1 and that's my y1. Now that I've got a point, and we're going to plug that right into our equation. So let's bring this straight down. I'll go back to red. And we're going to go y subtract, and we're going to substitute. So we're going to put in brackets my y1, which is -2, and that's equal to 3 over 4 is my slope. And that's multiplying x subtract, and again in brackets, my -1. Okay. Now, of course, we're going to simplify this no problem. We know that these are going to turn into addition, so it's going to be y plus 2 is equal to 3 over 4 times x plus 1. Now, some students think, oh, I need to multiply this into the brackets. No, this is slope point form, so we want to leave it just as is. Now, if I use this point over here, let's just highlight it. If I use this point over here at positive 3, 1, it's actually a completely valid solution. So we're going to say, or I could have set up this point, okay, which is at, looks like positive 3 and 1. We could use this point as my x1 and my y1, and we'll just plug it right into the same formula. Y subtract 1 is equal to, same slope, 3 over 4 times x subtract 3. And simplify that, we have subtracting a positive, so y minus 1 is equal to 3 over 4 x minus 3. Now, both of these are correct, and there are an infinite number of actually correct equations. As long as you put in the right slope, you can pick any point that falls exactly on this line, and it will be a solution. So if I were to plot this one or this one, I'd get the exact same line. So both are valid. Okay, One more question here. Let's write the equation in part A in slope-intercept form, and what is the y-intercept of this line? So this is going to be a common question where we convert from one form to the other. So it doesn't matter which one we're going to use here. I'm going to use the one on the left here. So let's start with our equation. We have y plus 2 is equal to 3 over 4 x plus 1. Now, remember, our goal eventually is to make it look like y equals mx plus b, some constant b. So we definitely got to solve this for y. Okay, so our first step can be either subtracting 2 on both sides, but better yet, let's simplify and bring in this 3 over 4 into the bracket. So we're going to multiply that in first. We got to get rid of these brackets because there's no brackets in slope-intercept form. And that's going to give me a new equation. It's going to look like y plus 2 is equal to 3 over 4 times x. And 3 over 4 times 1 is just 3 over 4. Okay. And now I'm just going to have to subtract 2 on both sides. Subtract 2, subtract 2. That's going to cancel on the left. And y is going to be equal to 3 over 4x. And here's one of those situations where we have to deal with fractions again. So let's just do that over here on the side. So we're taking 3 over 4 and we have to subtract 2. Well, we need to get a common denominator. Okay, so currently they are not a common denominator, so I'm going to multiply this one by 4. So times 4 times 4. It's going to give me a new set of fractions of 8 over 4. And now I can subtraction. 3 subtract 8 is negative 5 over 4, and that's a reduced fraction. So we can put that now right in there is my y-intercept. Okay, so the question said, what is the y-intercept? Well, that's the b value. So now we're in slope-intercept form. There's my slope, there's my intercept. So here is the y-intercept. Okay, and that concludes this lesson. In class, we're going to actually show that this equation up here will give me the exact same y equals mx plus b, the slope-intercept form, but we'll save that for in class. For now, that's it. We'll see you next time.